Hi folks, we're going to take a look at number 10 from the October 19th homework, and so here they're asking us to sketch this logarithmic function. Okay, so first thing I notice is I have a coefficient in front of the x that's not equal to 1, so now I'm going to have to factor that out. Okay, but hopefully you notice that there's a little hitch in this question here, because this input of 2x plus 3 is squared. Okay, now normally that would be a big problem if we were working with any other function, whether it was a square in an exponential function in the exponent, or if it was a square in a sinusoidal function. But here we have a way of rewriting this that eliminates the exponent from that expression, and that's our good old ski-slope rule. Okay, so it offers us a little more versatility when we're working with a logarithmic function. So I can rewrite this, bring down the exponent 2 as negative 2 log base 2 of, okay, and here now I'm going to factor out the 2 while I'm at it. Okay, so 2 times, and I'm left with x plus, I guess we can put it in decimal form, x plus 1.5 plus 2, and now this looks like a form that's much more familiar to us, because each of these operations can be connected to one of our standard transformations. Okay, so I think you've seen the way I perform these transformations is I pick a few points on the parent function, which in this case here will be log base 2 of x, and I transform those individual points. Okay, so let's start with 3 points here. So at this point, hopefully, we realize 1, 0 will always be one of our points. Okay, and then here, if you still want to think of this in terms of exponential expressions, 2 exponent 1 is equal to 2. So that means that when y is equal to 1, x is equal to 2. Okay, and instead of taking 2 exponent 2, let me take 2 exponent negative 1. Okay, so we get a point on either side of this 1, 0. Okay, so when y is equal to negative 1, 2 to the negative 1 is a half. Okay, again, at a certain point, hopefully you just start realizing that 1, 0, a1, and 1 over a negative 1 are always points on a logarithmic function. Okay, so let's transform these points now. Okay, so here let's see what happens. And by the way, if you actually want to write out the operations that I'm going to do here in my head, not a bad idea to write them out. In fact, let me write them out here. Okay, so let's take what happens to the x value. Okay, so the 2 in front, of course, anything that's horizontal is opposite, so it's going to be 1 divided by 2, so 1 half, and then here this is going to be the opposite of what I see, so instead of adding 1.5, I'm going to be subtracting 1.5. Okay, and let's see what happens with the y. Here gets multiplied by negative 2, okay, and then we add 2 from this here. Okay, so what do we end up with? 0.5 minus 1.5 gives us negative 1, and 0 plus 2 is 2. Okay, so there's my first transform point. Okay, so now what do I have? I have 1 half times 2 minus 1.5, and then for the y value, negative 2 times 1 plus 2. Okay, so what does that give us? It gives us 1 minus 1.5. Okay, so that's negative 0.5, and here negative 2 plus 2, 0. Okay, and last one here. So here we have 1 half times our x value of a half minus 1.5, and then we've got negative 2 times our y value of negative 1 plus 2. Okay, let's see what that gives us. So this is a quarter minus a half, or 0.25, sorry, minus 1.5. So this is going to be negative 1.25, or negative 1 1/4. And here we have 2 plus 2 is 4. Okay, so these are our 3 points. Okay, so unfortunately the printer's on the fritz, so I'm going to have to do this one by hand. So try to do as nice a job as I can. Okay, so I'm seeing here all my x values are negative, and it looks like all my y values are positive or 0. Okay, so I'm going to draw my graph to be mostly in this second quadrant. Okay, so let's make this a half, 1, 1.5, 2. So this is -1, -2, and then 1, 2, 3, 4. Okay, so now before I start, let me set up my structure here. So what's happened is now I have this translation to the left by 1.5 units. So that's where my asymptote is going to be. It's going to be at, oh, that's a very bad asymptote. Let's fix that up. Let's try again. Okay, so here, let me start from here. Okay, so my asymptote at -1.5. Okay, and let's plot the points. Okay, so we got -1 goes to 2. Okay, then we've got -1.25, so halfway there to 4. So that's about there. And then we've got -1/2 and 0. Okay, so there's that point there. Okay, now because I know what a logarithmic function looks like, so this is why it's really important to know what it looks like. Okay, and I know that it's been flipped around the x-axis, I can see that it's going to definitely have this form here. So along the vertical asymptote, and then it's going to eventually keep going downwards like that. Okay, so from there, let's sort of draw that in. And again, doesn't have to be perfect, but that's good enough. Okay, so now I'm tempted to just leave this problem here. So do my little recap. Notice here that the that it's squared, so we use the ski slope rule to bring it down, so I get a more traditional form for my transformations, and leave it at that. Okay, but if you plot this on Desmos, probably notice something a little different, a little odd here. Okay, this is where again we have to be careful. Sometimes when you do some algebra, okay, you sometimes affect the outcome, because the original equation had this 2x plus 3 squared. Okay, we bring it down, the 2 is in front. Okay, now let's take a look at this input here. This input to the logarithm has to be greater than 0. Okay, but let's take a look at the original equation. Okay, the original equation, okay, has the 2x plus 3 squared, meaning the original equation will allow 2x plus 3 to be negative. Okay, and so there's going to be more to this graph here. Okay, so in other words, if we just kind of take a look at just the input, log base 2 of, so if 2x plus 3 is already a positive number, and think of how we did this early on when we were talking about piecewise functions, okay, and we were talking about absolute values. Okay, if this is positive, this is 2x plus 3 squared. Okay, but say 2x plus 3 is a negative number. Okay, this is what the input could look like. It could be written as the negative of that, of what the original expression was when it was positive. Okay, but then when I bring down the 2 in this scenario here, I end up with this negative inside here. And what does that negative represent? It represents a flip in the y-axis. Okay, so there would have been this flip in the y-axis for the portions where the original expression had the 2x plus 3 being a negative number. Okay, still can't be equal to 0. Okay, just because you're squaring it, the input still can't be equal to 0, so you still have this vertical asymptote. But what you're going to have now is you're also going to have a second branch to this equation, which is going to represent a flip in the horizontal asymptote, which was originally, the reason why it's around the horizontal asymptote is the horizontal asymptote was originally along the y-axis. And so what you'll see on Desmos will be something that looks like this, where it'll have sort of a mirror image on the other side. Okay? So certainly, if I were to put something like this on a test and expect you to get that, well, that might be a thinking question, okay? Because you have to think about the fact that the original equation had been squared. Certainly not something I'd give as a knowledge and understanding or application question.